I have second hour. They tell you about that? Oh, is it started? Oh dear. Hello everybody. Sorry, 7 minutes late, seconds later. Okay, here we go. So first thing we're going to do is make a table of values, and then this is just looking at parametric equations in terms of trig. Okay, so off to the side, what we're going to do is nope, that's a bad start. Make a TXY chart. And we should do more than these angle measures, but for time, and then when we look at this rectangularly, we'll tell you how the things get filled in from there. But we're going to go a full rotation on that old unit circle and think about what happens when we plug in these values. Okay, what's the x component when you plug in 0 for t? What sign of 0? 0. What's 0 times 5? 0. Off to a roaring start here. What's cosine of 0? 1. What's 1 times? It's 1. All right, and I guess what you could oh, there it is. Was fighting sinuses all weekend too. Anyone else? Sinuses flaring up? Colds or anything? I'm thoroughly positive that mine's allergies. I think I'm on a downswing though. Doing well. What's sign of pi over 2 now? What sign of pi over 2? 1. Ooh, he's looking. Times 5 is what? 5. Let's turn that into a 5. All right, and what's this cosine of pi over 2? 0. What's the sign of pi now that the ball's rolling here? 0. What's the cosine of pi? -1. What's the sine of 3 pi over 2? -1 times 5 is -5. What's the cosine of 3 pi over 2? 0. Then you end up getting this again because it's the same thing as 0. So if you were to take a look at this picture in rectangularly, what would this be a picture of? So 0, 1, 5, an eclipse. What is that? -5. I don't know. Did he? I thought I heard that. Possibly, Now, what we're missing, okay, fine, we didn't really, we talked about it a little bit the other hour, especially with our later graphs. If we fill in all the other pi over 6, pi over 4, pi over, these would connect. They would connect in a weird way, though. From 0 to pi over 2, this would be this part. Then from pi over 2 to pi, we went from 5, 0 to 0, -1. Then from pi to 3 pi over 2, we'd get this part. And then from 3 pi over 2 to 2 pi, we ended up back up here. Okay, so we didn't fill in all those other parts, but we could and get those little x, coordinates and y coordinates. All right, now how do you convert this? How do you convert this into eliminating the parameter? I almost said it the wrong way. This is what you do, and this is weird, wild, wacky stuff. Luckily, we have sine and cosine. What formula does both sine and cosine exist? Like, what do you have that? What trig formula from your favorite chapter 5? Sine squared t plus cosine squared t equals 1. So now what I could do, remember what sine squared t means. That meant sine of t, then square it. Cosine squared t means cosine t, then square it. So I'll just scratch them out, write it that way. Now we can do a replacement. X over 5 squared, or a better math word would be a substitution, I suppose. And then when you're done, lo and behold, you have an equation of ellipse with an x-axis radius of 5 right and left, a y-axis radius of 1 up and down, and a center at 0, 0. Right? So it all coincides. So this makes you happy at the end that, and more, confident that these points over here that I did parametrically graph to be an ellipse. Okay. All right, so that same 0, pi over 2, pi, 3 pi over 2, 2 pi. This one's a little strange what happens on this one. What's sine of 0? 0. What's cosine of 0? 1 squared is? 1 times 2 is 2. Let's put that graph up here so we have, 0 comma 2. What's sine of pi over 2? 1. What's cosine of pi over 2? 0 squared is 0 times 2 is still 0. 1, 0. Strange. So if we go from 0 to pi over 2, it looks like we have something that connects from here to here. So what might be smart is wait till you do the rectangular equation, what you expect out of the picture, and then see what kind of picture it is. That's the way I have to do it. I'm almost like with you guys as far as the introductory level of looking at this stuff. So that's how I would approach it. All right, pi. What's sine of pi? 0. What's cosine of pi? -1. But what's -1 squared? What's 1 times 2? So this is what happens from 0 to pi over 2. We go to here. And then from pi over 2 to pi, we come back. Because the negatives get squared and get, flipped over the x-axis in a way. Don't worry about what I just said there. What's sine of 3 pi over 2? -1. What's cosine of 3 pi over 2 squared and then times 2? Still 0. Oh, for the love of dog. That happened Friday, didn't it? And then, of course, 2 pi. So that's the same thing. It comes here. Then from 3 pi over 2 to 2 pi comes here. Then why do I not do anything else after that? Because what happens after 2 pi? Repetitive angle measures, and it's just going to keep happening. So the next thing we should do is, all right, let's look at this rectangularly and then figure out what we have. By the way, it's a parabola. Okay, so cosine squared of t equals y over 2, divide by 2, and just sine of t equals x. And then what do we say is the bridge, I guess? Sine squared t plus cosine squared of t equals 1. Hey, what do I put in for cosine squared? Just y over 2. It's already squared. What do we put in for sine squared, though? X squared. Now, what we should do is put it in the form that we're used to lately, which is subtract y over 2 plus 1, and then pull out a negative 1/2. When you pull out a negative 1/2, what does that 1 become? What does that 1 become? -2. Yes, this is a parabola with a vertex from 0 or at 0, comma 2, as noted up here. But the problem is this is limited for x values from -1 to 1 because of what happens in the original parametric equation. And of course the range is only from 0 to 2, but that's what you're limited as far as graphing this parabola. So it's not the whole thing, it's just this little chunk. Okay, now, no, I didn't. Oh, what's the secant of 0? Okay, by the way, probably want to put this again right here. What's the secant of 0? What's the secant of 0? 1. What's 1 times 2 minus 1? 1. What's the tangent of 0? 0. What's 4 minus 0? 4. I don't know how this is going to work out. I just thought I'd play around with it, though. What's the secant of pi over 4? It is root 2. Now, get your calculators out. What's 2 times root 2 plus -1? I'll take it as a decimal, and I'll hold off on the movie. What's the y component? What's the tan of 45? That's easy. 1. What's 4 minus 1? 3. Okay, let's go back to this then. What's the secant of pi over 2? Ooh, interesting. What's the secant of pi over 2? Undies, as someone so nicely said, second hour. Because what's undefined times 2 minus 1? Undefined. And then what's tangent of pi over 2? What's tangent? Bless you. What's the tangent of pi over 2? Undefined. What's 4 minus undefined? Undefined. So I bet you we have something there. Something going on. Undefined, comma, undefined. All right. Let's go to 3 pi over 4. Oh, what's the secant of 3 pi over 4? Then type it on our calculator. Negative root 2. So do negative 2 root 2 minus 1. I just want to get that value and just kind of analyze it. Negative 3.83. Now I think we'll be good with the calculator help. What's the tan of negative, or 3 pi over 4? I accidentally slipped out. What is it? Negative 1. What's 4 minus negative 1? 5. Okay, so we'll just analyze those points when we look at this rectangularly, see how this picture shakes out. What is secant of pi? Okay, sorry. Secant of pi is, yes, negative 1. What's negative 1 times 2 minus 1? Negative 3, and I just moved this over. I don't know if these extra points in the middle, you need a lot more probably to get more shape out of the picture, so on and so forth. 5 pi over 4, isn't a tan of 5 pi over 4? Oh, okay, no, this is a little different. What's the secant of 5 pi over 4? Negative root 2. So when you agree, that's negative 3.83, right? Right? Yeah. What's the tan of 5 pi over 4? 1. What's 4 minus 1? I'm sorry, I forgot this one. What's the tan of negative 3? What's the tan of pi? 0. What's 4 minus 0? 4. Right? I forgot that one. Okay. What's the secant of 3 pi over 2? 3 pi over 2 is right here. Are you okay over there, sir? Big size over there. Undies? Right? What's the tan of 3 pi over 2? Undies. What's the secant of 7 pi over 4? The positive root 2, right? So what did we get? A positive root 2 times 2 plus negative 1. Wasn't that the 1.83? Right? That's the tangent. Hey, what's the tangent of, where are we at? 7 pi over 4? Negative 1. What's 4 minus negative 1? 5. I don't know how this is going to all look out. We'll do this when we go rectangular. More than what we did the other hour. Just for fun. Secant of, and they're just having a blast. Isn't that 1 comma 4? Poor second hour. You didn't get to have all this fun. Okay, this is wild. What's secant of t equal to? Now what we're doing is eliminating the parameter. Add 1. Divide by 2. What's the tan of t equal to? I always do that with tan. I forget the a. Subtract 4, but then divide by a negative. Well, it seems like 4 goes with y, because my y's always look like 4s, and then, I don't know. What is the bridge? Oh, I could do that, but that would be, I don't know what we do after that. What? Oh, you were right. I think one of those things you said. 1 plus tan squared equals secant squared. I think you said secant squared minus 1 equals tan squared. Is that wrong? No. You just did a alternative form to the original. And then 1 plus tan squared. By the way, this I don't think this blew anyone's mind, but did you know 4 minus y squared is the same thing as... Wait when I solve. Let's continue. X plus 1. Yes, it is. He said it. It's the same thing as y minus 4 squared. There's 2 reasons. One, when you FOIL this and you FOIL y minus 4 squared, you get the same thing. The other reason, I'll do it right now. This could be rewritten as negative 1 pulled out, and then y minus 4 is what the result is of that. Still squared. What's negative 1 squared, everybody? 1. So I'm going to write it like that so that we can recognize what this is and what the important components of this is. So what do we have to do? We have to solve for y. What? We have to solve for 1. Leave this as x plus 1 squared, but over 4. Subtract that 4 minus y squared from both sides, but then make it y minus 4 because of what I just told you, over 1. And that equals 1. What is this a picture of? Hyperbola with a center at negative 1 comma 4. All right. And then an x-axis move right 2. So we get 1 comma 4 as one of my vertexes or vertices. And left 2, which is negative 3 comma 4, which is another one of my vertexes. Do you see it? Do you see it? Do you see it? Okay, circle them on the chart. And then if you continue the rectangular, you'd have to go down 1, up 1. And of course, everything else is going to be decimals, and I'm going to try to locate the points that I see in my chart that I added. And I'll do that offline because I think you get the point of how to graph a hyperbola. And draw it. Ugh, it was a terrible drawing. I bet you some of these points will shake out like 1.83 comma 3, right? Isn't that about a good representation where that's at? Okay, so we got that one done. Negative 3.83 comma 5. That's somewhere up there above 4, right? Oh, I'm so excited. Okay, and then negative 3.83 comma 3. Holy crap. Yeah, these are the reflected points. Oh, I'm so excited I did this. And then 1.83. Are you kidding me? 1.83 comma 5. Hey, there's that point. I'm actually surprised that happened. I didn't even know that was going to happen. I just made my day, people. They don't have that online. Remember when you had to you had an f of g of x question equals h of x, and I gave you h of x, and you had to come up with f of x and g of x that made this happen. Composition of functions. Remember that question? Well, you should go back to our old calendars. Find those notes. I forget what chapter it's from. So that's really what this is. This is an eliminated parameter equation. This is a rectangular equation. What would x have to equal and y have to equal in terms of t to make this happen? And actually, second hour came up with a real unique one. I was like, wait a minute, is that right? And then I did the work and it worked. It was awesome. So I want you to think about it and see what would x have to equal and y have to equal in terms of t, what just happened, so that this would be the rectangular representation of. He's correct. Why? Because what would you have to do in order to, eliminate the parameter? You'd have to solve this in terms of t, which is what? How would I solve this in terms of t? T equals x squared by squaring both sides, and then wherever there's a t, I'd have to plug that in. Right? So good. Does anyone have another one? Or does this work? It is kind of weird. Which one would you do first? Maybe solve for y, or would you solve for x? What do you guys want to do? Hold on, let's check it. Okay, so let's check it. So if you solve for t for y, right? Then this goes in there, right? What would you do next? What would you do next? Hurry up. Square both sides. What's everyone doing? Then what? And then what? It would work. And I think that's what second hour came up with. Oh, it wasn't. Oh, it was -4. Okay, then it would be. Okay, got it. Because it ended up being -4. So we'd have to switch it. My bad, dogs. I didn't catch that. Kind of weird, huh? All right. One more. I think maybe calculus when they do parametric equations. If they do, I have no idea. Never taught it, so it is a bummer. But that's what that represents parametrically. Over time, this is the vertical move of an object, and this is that's the horizontal move. This is the vertical move. So all she wanted to ask you is, if that's the case, what if I shifted this parametric equation 4 to the left. Who does that affect, x or y? X. Ain't no thing. She just wants you to think about it. T to the fourth what? 4 to the left? 4 to the left is minus 4. Now doing opposite. You're moving everything 4 to the left, so you're subtracting everything 4 to the left. Okay, what about up 1? Who does that affect, x or y? How do you move something up 1? Add 1, but then vertically stretched by a factor of 2. If a y coordinate's 2 and it's vertically stretched by 2, what does it become? 4. If a y coordinate is 7 and it's vertically stretched by 2, what does it become? 14. So what happens to the y coordinates? They get doubled. So it'd be 2 times t, and then after that you'd move them all up 1. Right? So that's what what's 2 times 2t? 4t. Then last but not least, write this as parametric equations for the curve. And then we'll go from there. So this is a reversal. Okay, by the way, what's that a picture of, number 6? This is the last one we're going to do. What's this a picture of? A circle. Okay, by the way, this is how I taught circles anyway, and this is what you want to do. I want to divide both sides by 4. Hope you're writing this down. Hey, in trigonometry, what else equals 1? Sine squared plus cosine squared. So what does that mean sine squared could equal? Remember this? A plus BI equals 7 plus 4i. What's A equal? 7. What's B equal? This is just a matching solve of equations. You know, if I put a 7 here and a 4 here, then this is balanced. So if I put a what here, fumble! Oh my gosh, that was a student, medic! All right, somebody's hurt. Sine squared equals... Actually, the way I have this listed, I'm sure it wouldn't matter if you switched them, but the way I have it as this is what we'll do. And then cosine squared of t equals y squared over 4. What are you going to do to both of these? Like sine squared equals blank squared? Square root? Yeah, I'm worried about the plus minus on that. I'm going to come back to you on that. I'm going to leave it off right now. Because I think that would give you 2 different sets of equations on this one. That's a tough one. I'll ask, what's her face? I mean, Cooper. That's terrible. Wow. Yeah, it's online. That was just a random thing that I usually say when I don't want to think about a name. Because my brain's losing spots to store things. So the names thing is kind of like going away, you know. By the way, this is not, you want to get this to be x equals and y equals. So what's x equal? Multiply by 2 and then subtract 5, right? And then this one just multiply by 2. Now I did stop here with the other. Actually, I didn't go this. I didn't solve for y and x. I stopped. I think we're good for right now. Give an appropriate window to sketch. And then how could you graph the top half, left side? Remember when I was doing this and creating that ellipse? You know, how did we get those parts of the ellipse? Where did that ellipse go? Remember that? Analyzing what coordinates gave those. I'm going to stop here. Just be happy that we have this, and maybe we'll talk a little bit more tomorrow about that and these other questions. I think we're good for now.